Hello, thank you all for coming to the talk. I want to give you some insights on how to actually deal with compliance if you're not actually coming from a compliance background, because I did that in the past. It was a bit challenging, but actually once you know how to deal with it, you actually can get through it much more easily. For myself, I'm working currently as a CTO, so I have a lot of things to do in that regard, but my background is coming from the point of data engineering and ML. Put it simply, I wanted to load Parquet files fast. So I came up and worked on Parquet, realized, to load them fast, I needed working. So I came to the point where I thought a bit about packaging it and got involved with Conda-Forge. And nowadays I want to load Parquet files fast in a working way that's actually compliant with all those regulations, which brought me then out to work on this. Recently, I went to something called the ISO 27001 certification. And I'm happily now through it. It has been a lot of work. The next thing I have to deal with is the Cyber Resilience Act. We'll go into detail what these are, like sufficient for you. But I want to share some insights how you actually can deal with that as yourself if you're a software developer. First of that, I want to introduce a bit why you should be actually dealing with that, why you shouldn't be passing it on to someone else. Then give you a bit about the theory, how you can actually understand what the things actually want from you. And the last part, I want to actually give you a bit more practical example, like what's happening, what can go wrong, what do you have to do, so you can actually make use of that and get easily around there. So, why care? There's this compliance. Sometimes you even don't know what actually compliance means because someone is coming in. But compliance mostly means you should follow some rules, regulations that guide a certain behavior of your thing, what you're doing. There's normally not the one compliance thing, but it's always like these things that they cover a certain aspect. And the main motivation why these exist is that you actually want, in the thing you're building, you want to reduce a certain risk, and you want to build up trust that somebody thinks, yeah, this is a good working thing, I trust it. Mostly likely trust it with my highly valuable data or highly valuable business decision. And this compliance is checked, but it's checked in certain scenarios. Like if it's important for your company because it covers some business risk, there will definitely be a compliance officer at a medium or larger size company that will look after the compliance. If it's something you need to adhere by law or something a client wants from you that you adhere to it, there will be an external person coming in and checking whether you follow actually these regulations or rules. This person is called an auditor. They will look for everything you documented, how you work, and then will maybe give you a stamp at the end, like this is compliant. Or the more dramatic thing, if something goes wrong and people want to know, was that by accident or was it because you was just vibe coding and didn't care about a thing? And then it's the point where people will also check whether you've been compliant in the past and whether your behavior is actually one that is okay or meh. And furthermore, I said there's compliance officer at the company. There's typically one designated person at least who has the title of Chief Information Security Officer. They get a chief because they're not allowed to be in a hierarchical position somewhere below anyone, which they can tell you should be doing something else. But their task is actually to check that everything is fulfilled. That's an important aspect. They're not there to look after how it's implemented. They're looking after that everyone should know what they should be fulfilling and that they're fulfilling it. And for you, you're the person normally, if you write software, you're actually the person who needs to fulfill these criteria. It's not them. They have other incentives, which is okay for the position, but can't make your life hard. But for you, if you know ahead of time or you know just by setting up something that these things will come at a later point, you can also already make some design decisions, because if you know what will be coming up, you can make things simpler, you can make things so that you can get through that. And basically, if you think, are you going to be affected? I can tell you if you write any kind of code, it's actually going to be affected by some kind of rules, regulations, or so on. So just be proactive, you will do something there. And on the other side, don't let yourself scare anyone by you telling you to do certain things. There's quite often the people coming in with simple, strict requirements, which sound overly complicated. For example, the default compliance thing is nobody should have admin on their laptops. I don't have yet seen a regulation that tells you to do that. It's just if you want to fulfill a lot of criteria, you can just remove admin on your corporate laptop. but actually, if you think about it and why you do that, that's not necessary. And there's a lot of other things where if you lock something down, it's probably not going to be the right decision, but it's just more the easy one from certain aspects. So be careful on what's happening there and what people push on top of you. But still, there's a lot of talk, especially on social media, about the EU being over-regulated. There's a lot of things coming in. I think 1 year ago, I didn't even know what this over-regulated means. So I don't expect that most people here will actually know what kind of regulations affect them. But if you look here in the EU or more European countries, there's already some regulations that's probably likely going to affect you, what you're doing, or some things people will want to require. One of the basic compliance topics is what most companies will have pop up, not by a regulation, but because some of the clients will want to use, is that they should be ISO 27001 certified. And in the US, you probably do SOC 2 for that, but it basically tells you should have an information security management system, or more plain words, you have a documented process that you thought about your information security stuff. It's more like you have thought about it, you're taking the right measures, not telling you you're taking these measures, but you should have come to a point where you're taking your own measures. But then again, on the regulation part, there's more specific things. Like there's the DORA Act, which takes care of digital operations in the finance sector, or there's NIS2, which puts some regulations on critical infrastructure related to information systems, which critical infrastructure is like energy companies, transport companies, or also the health sector, which is then also another industry-specific thing. But there's also more generic things. The Cyber Resilience Act is one of the more simpler ones, but it's also a bit more simpler because it affects nearly everything that has some form of digital element, meaning software so in it. So it's a thing that regulates if you supply one of these goods, like a smart bulb or a smartphone app or a smartphone, like the whole range on what you have to do to take care about cyber risks there. And actually, from a consumer perspective, this is a really nice thing, because finally I have some information on what kind of software is running on my smart device, which I don't trust in my network. But from a vendor perspective, you need to fulfill some things. One more thing that's often in these discussions, but I'm not going to touch deeply here, is the AI Act, which deals about AI models, and it's going to be affecting you if you do a high-risk application. There's also certain things in there for non-high risk, but if high risk, maybe doing life-changing decisions for people, then you need to take care of that. And there's more regulations existing, more to come, but they all have their own meaning. Going a bit more, in the theory perspective, what does it mean to comply with things? And complying means you have to think about actually, in all these cases, what's actually the thing that's going to be risky for you, what you are doing in your daily work, what's risky to you, your company, your clients, and independent of any of these regulations, all of them will be there to minimize risks. And minimizing risks does not mean minimize all the risks, but first of all, you should be thinking of, okay, what kind of risks do I have? There's certain guides that help you to go through the process, but a simple approach is first find out which risks do you have, then look at the risks. Are they really bad if they happen? And make a 2D matrix if they do they really happen? Because this is also, there's certain things that if they happen, they're really, really bad, but they're really unlikely that they will ever happen. And there are also other risks that are like, yeah, if they happen, that's not so bad, but it's probably going to happen this year. And there's also the combination, they're really bad and they're going to happen. And once you have this 2D matrix, you have already a score for them, and then you can prioritize based on how you're going to interpret this 2D matrix for your company. What are the highest risks you actually need to take care of? And then think about, okay, let's first go to highest risk and think about how can we treat them, how can we make it certain that these are not that risky, and find treatments, like making them less probable or the impact less severe. And this list is quite good, because then you have something, priorities thing to work on. And also a nice thing, if somebody comes up to you and says, okay, we need to ensure that certain service is not going to have internet access. And if you look through your list and say, okay, this is a kind of awkward requirement because it needs to crawl data from the internet. But that's one point where you can think of, okay, it's not sensible. But the other thing is, there's no risk on my list, actually, that tells me to ensure there's no internet access. do you know a risk? And if the person who wants to enforce this thing on you doesn't have a good risk, it probably means you shouldn't be working on that, and probably means that's not a measure that's important in your case here. One of the typical risks we have here, which is, it's not theoretical, but it's in theory we need to look at it, because the most thing is actually malicious software updates or things coming in through third-party software. There has been a lot of things in the news in the last 2-3 weeks, because there was a lot of package compromises on NPM, which I think this is one of the first posts on Blue Sky about it, but there were many more coming afterwards. Because we write code, and the code is depending on third-party software. Like, nobody is here in the room probably writing everything in a sampler from scratch. So there's third-party code you base up on, and third-party code is also one of the most likely sources of impact if you write software. It's not industry-specific, but it's specific to that, yeah. It's going to be everyone who's doing stuff here. It has software as the thing they base up on, and they have certain attack vectors. And so you need to think about in software, okay, these kind of dependencies, how can they affect my workflow? And the thing is, you have to always look at all dependencies, not just the production ones, but also the development ones, especially in the case if you work with data, because you will have in your development setup where you train a model or work iteratively on a model, also some kind of valuable stuff around. So things can go bad already there, not just in production, but also in the development phase. And typically, you will have hundreds of dependencies in your environment. And there's also one thing called phantom dependencies. Dependencies are normally the ones you're aware because they're in your requirements.txt file or in your conda environment YAML file. You will see, okay, these are the things I depend on. And you can ask your package manager with a list command, okay, these are the dependencies I have all inside the environment, also the indirect ones. But phantom ones are the ones which your current package manager doesn't actually show to you, but they still exist in your environment. They still can be vulnerable. They still can have an impact on all the things you're working on. And for that, it's important, like with the risk, first be aware of what you actually have. For that is the thing called AIBOMs. I think that if you touch software and compliance, and AIBOM is the first acronym, or the one acronym is in all the documents. It's basically a list of all the software packages in your environment. And you should be just generating one if you want to look in an environment to get to know what you actually are using. And the important thing is, don't use the list command for these things of your package manager. Use a package manager independent tool like Sift or Trivy, which actually looks at what you have installed, because they will find, or they not always find all dependencies, because there's still some cases where it's not totally visible, but it will find a lot more than you actually expect. And once you know what you have, make sure you always are certain that what you have is actually the thing everyone else is going to use, not that you do an installation. If you deploy the software somewhere else, something else is there. Just have, like in the previous talk, a log file, which basically pins down these are the versions that were used, and then you have intentional updates where you say, okay, now we're going to use new versions. And the good thing is for any malicious software or vulnerable software coming in, we have this process that there is CVEs generated vulnerabilities, and there's vulnerability scanners that can take the software you have locally installed and match it to a CVE list telling you, okay, these like 10 packages here have a vulnerability, please think of maybe upgrading them. And then you already know, okay, you can work a bit on that and get like the risk a bit down. But before these things like vulnerabilities actually happen, you could minimize that also by looking at, okay, my dependencies, where are they coming from? You maybe check some of your major dependencies on, are they actually developed in a nice way? And then think of whether you want to depend on or not. That's a more costly process than looking up after the fact whether you're runnable, but it maybe will save you a lot of work later on. There's no one real way to do it, or maybe there's one real way you can inspect all lines of code of a package and all things they do. It's going to be taking you a lot of time. There are certain heuristics you can use. The most common one is the OpenSSF scorecard, which scores projects on their security heuristics behavior. It's just heuristics. If they say it's good, it's probably good. If they say it's probably bad heuristic for that. For machine learning models, if you have a third-party model, there's nowadays something like model cards, which give you, depending on the model vendor, and information how the model behaves, how it can go wrong, what are certain things they already tested. But in the end, you can minimize the things that can go wrong, but still there's the point where something will go wrong. So have plans available, what you're going to do if something goes wrong, how you're going to update your software immediately or so. And another thing is understand actually who's writing the code that you use, because it's normally not a single package you're going to use, but it's a package that's written by or a set of packages going to be written by a community, like the PyData ecosystem, or the package manager also. There's a community around of them. If you know the community, you know how much you can trust or not trust it, or what certain aspects you need to cover. Still, you write code, and a lot of studies, like I don't have a concrete one, but I've seen lately someone saying that like 90% of their bugs are in their own code, and bugs is a misbehavior of your software, and that's a risk. So, and I said before, compliance is about minimizing risk, so minimizing bugs means also minimizing risk, meaning that if you want to have a good project, make sure your dependencies are well tested, but in the end, the dependencies you're using, they're really well tested because they have a lot of other users also using that, and you're probably most likely going to use one or two edge cases, but mostly you're just going to use them in a default way, so you're not triggering edge cases there. But your code is like at the forefront of your application or your pipeline, and then you're typically not just using the main use case of your code, but it will trigger a lot of edge cases there, and then it can go wrong. And for that, just do things that help you to ensure that these things are minimized in a simple way. Like, a lot of the compliance things can be done by doing a lot of checklists, being a lot of aware, going a lot of things, but the more actually as a software engineer I can automate stuff, the more I'm happy, and the more that means the less I have to take care of it immediately. But there's still some things I cannot really fully automate. It's like mandating code review or good code review. If somebody just approves my pull request, it's not a good code review, so I should write down somewhere what actually constitutes a good code review, that my colleagues know, okay, if you do a code review, at least check these things. And if I write that down, that's also quite nice, because auditors externally coming in, they really like to see a bit of documentation, because otherwise for them, they need to go through all of the stuff, think about did they do it or so. But if you write good documentation and can tell them, okay, everyone's adhering to that, checking your stuff is going to be a matter of minutes, not of days. Still, if you want to do good code review or do good coding, you need to train some people that they do it in a nice fashion. And if you actually have a service that's externally reachable, go and invest in a pen tester. There are some people that actually know security much more than you, or maybe they don't know as much, or they don't know it on the same level as you, but they're external, so they will have a different viewpoint on it, so they can reveal a lot of things on you on top. If the stuff you're doing is not externally visible, also maybe that's not worth it or not going to give you any insights. But still, the one thing that's worth it, just use as much automation that can tell you about the simple issues you could run into. Run linters, run static analysis, make sure they're configured in a way that they don't pop up noise, but actually tell you good information so that small, simple mistakes that can have a big impact already detected quite early. Which will minimize that. And with that, I want to go a bit into practice. And we can think of a really simple example. We want to train a model on some CSV files. I'm actually removed the service from here because this already is a good point where we can see where and how things can go wrong already. Also, I'm trying to stick here to just generic things. And not a single regulation, because if you concentrate yourself on fulfilling one regulation, you will have a hard time with all the other ones. If you stick to the normal case and just thinking, okay, compliance means reducing risk, and all the risks I have and all the problems I may not have later, it's just good to do this at one point, because I think my experience is doing it for one and doing it in the general. The general case is like 30% more work. Otherwise, if you do a second one, you will have the same work again. And yeah, in this example, train a pipeline, simple Scratch setup. I will use JupyterLab, I will use Polars, I will use scikit-learn and LightGBM to have some dependencies. This means, and I use my favorite package manager, Pixie, for it, which instantly gives me a log file, but also Pixie can list me the dependencies. The first line is the header, and the other ones are the dependencies, which gives me 159 dependencies in this case. And I've talked about phantom dependencies before, so it's not going to be 159. For that, we're going to make a scan with Sift. Sift is going to analyze all the files I have on disk in my environment, and I will put out an SBOM so I know there is, for later documentation reasons, I know what's in that environment, but also get a nice output of how many files and how many packages. And there's a surprising number of 2,382 packages, which is a lot for a really simple Python environment. And also, I'm using Pixie, so Pixie is not actually tracking just my Python dependencies, it's also tracking all the native dependencies I have on my system. So it's quite astonishing to see so many packages, which if you think of any package is going to be a risk, it's an awful lot of them are packages. And it's a fresh environment, so there's probably not going to be any vulnerabilities in there, because new software, freshly just installed from the indices, no pins on there. So there's probably not have been time for people to look into it, whether there are any vulnerabilities. And if people release new software, they probably have fixed all the vulnerabilities. But if I run a scanner on it, I get a long list of like 19 vulnerabilities. And there's some in there where you can see they're red, they're high, some they're medium. And yeah, that's not good. Because if you start out fresh, you already have so many vulnerabilities. How are you going to look at that in a week's time when the software has aged a bit, or like in a month's time, and you have to think about how to fix all of them, because all vulnerabilities mean all of this code is actually meaning your service is vulnerable, can be hacked, and if anyone's going to check your compliance, you're not good. But there's a nice column in the middle which tells you the type. And that's the thing where you need to think about, again, risks. Most of them are actually NPM packages coming out of Jupyter Lab. Jupyter Lab has a lot of Node.js code for extensions, and these extensions, they need it for the case where you install a new Jupyter Lab extension. You need to recompile some JavaScript code and so on. But in my case, I'm training a pipeline. I'm only using Jupyter Lab to show a Jupyter notebook. I'm not doing any extensions installation, so I don't even need to think about are extension installations a critical thing or not. But I can say in my case, that's not a risk. I can ignore all of them for now. For me, there's two things. There's an actual conda CVE, but it's classified low on the Python binary. I should look it up, see whether it's actually also affecting me. There's not yet a new release Python version on that, and it's a CVE from 2024, seeing in the version name. So it's probably not going to be like that bad. And we got a lot of these, like thousands of packages, because I intentionally used polars instead of pandas, because polars is a Rust package, and Rust is statically compiled, but it means one single binary contains about, in this case, I think over 1,000 dependencies, which makes my list quite long. And there's one in there which has a medium vulnerability. And I think if you look at it, it's also one that only affects if you do something with external data. So actually, we're quite fine. It's a long list, so important takeaway here is there may be long lists, but it doesn't mean that if there's something popping up, it means you will have to take care of it. It more means think about your context. Do you have to do it? So this list in another context could be really severe, but in this case, it's okay. Trusting the software, one simple example is the OpenSF scorecard. As I said before, it gives you a positive indicator as a software like following good security practices. Here one example from my colleagues, which we spend a bit of time to actually follow most of these things. And if you get here a software with a score of 7 or above, you know, okay, they spend some amount of thinking of how to make the software development process and the deployment process secure. We're probably fine here with those, though. They will not have some likely, like a malicious package incident or so. If it's giving you a score of 3, doesn't mean the package is unsafe. It just means you have to look somewhere else. In some cases, it could be a problem because it's a package maintained by a single person who just releases it from the laptop and the source code is not shared. Or it could mean that they just use another process which is not covered by the scorecard, but is maybe even more secure than my example here. And getting back to one thing I wanted to have for this like simple pipeline, short risk assessment. because risk assessment is the first thing you need to do, because you need to think about what can go wrong. And this important thing, don't do a compliance regime, like one a certain act, but just think of all the things that can go wrong. Because in this simple pipeline example, where you just get a bunch of CSV files to train a model on it, and at the end have a model, you have some issues that can pop up. For once, your CSV data may be containing some malicious inputs, either inputs that change your model, make it misbehave because it's a certain number that just triggers something in the algorithm, or contains some certain characters which then come to the point that the code misbehaves, or actually if you use then a vulnerable version of like LightGBM that actually runs to remote code execution. And even if you're running it on your laptop and it's an air-gapped environment, it can have like severe impact. Like if it's air-gapped, probably data is not going to be exfiltrated to the internet, but it could just delete your machine, so data is gone and don't have a backup or so, or some days of delay. So that's even a development setup. The combination of these things can be critical. And at the end, also one of the risks is that we don't version things correctly, model data or so, and later on the point where someone wants to debug the model, we come to a point and they say, yeah, can you tell me how you trained that model? Can we look into the process how this happened? And if you don't think about that, that's maybe also a liability. So it's not always just the software or so, but it can also be a bit about your process, what you use for training. Making one example, because I'm running out of time, is we look at the CSV files. If they're coming from a source we really trust with like simple data, it's going to be low in the impact. If it's like CSV data fetched from a random internet source, likelihood there's something wrong, there's more medium. But in the end, if it's corrupted and can have an impact, the impact is really high, because you can delete data you don't want to, or your laptop gets infected with something, because people manage to put like data into CSV files that actually trigger some remote code execution. And for that, there's simple things you maybe already heard of in the case of making your model better performing, but in this case, you can use it to also increase like the security or risk aspect. Just validate what you get as input, validate the schema, and limit the privilege of the process. Like the principle of least privilege is a typical thing that's coming up in all these compliance things. It's just meaning if you do something, do it like in the way where it has the least amount of access. So it just works, because if something goes wrong, there's not so much you can do wrong. Yeah. And with that, I'm out of time and happy for questions.
Thank you so much, Uwe. Is there one question for our speaker? Sorry, I can't see very well. Can I see? Oh, sorry.
Concerning the versions of packages that can be corrupted, we have like Dependabot in my team, and we have like to go through like risks where you say like you have to bump to a certain version, etc. And we have like to do it manually and then look at the changelog to see if any major changes. So do you have any like way to automate that and still be like effective?
So the easiest way is always, if you can update and it's not a breaking change, just update, because then you don't need to think about it. Otherwise, it's often, for certain packages, just know where you're using them, because if you know they're really in an uncritical point of time, you can say, okay, probably vulnerabilities there, they're not relevant for me. Because like vulnerabilities also come with a category, and it's like if they have like an internet access thing or so, and you know this is running in an air-gapped environment which just doesn't do that, it's probably not going to affect you. When you have a point, sometimes things pop up where you really need to look at it. It's kind of a cumbersome task, sadly. So we also spend a lot of time like manually looking through these things and classifying, declassifying them. The Jupyter example for me is one simple case. They have a lot of Node.js code there. It's running in a really like, mostly if we run that and installing Jupyter extensions, it's a really uncritical environment. So we know it is not going to be important. It's not going to affect anything there. So it's okay that these things pop up. And then you can like always say, yeah, we can ignore that, it's no problem. But that's, if you know the context, and then you can make it a bit easier.
Thank you so much, Uwe. Big round of applause, and then we'll change speakers. Thank you.